Good evening, everyone, and welcome to the Real Science Exchange, the pubcast where leading scientists and industry professionals meet over a few drinks to discuss the latest ideas and trends in animal nutrition. Hi, I'm Scott Srell. I'm going to be your host here tonight for our discussion, and I've got a brand new, spanking brand new co-host, Dr. Laura Niehues. She's new to Balchem and also new to the Real Science Exchange Pub, so welcome on both accounts.
Thanks, Scott.
So, two questions. One, what's in your glass? And then two, I'd like you just to talk a little bit about yourself. Tell us who you are,
Yeah, of
that kind of
course.
thing.
I have gin and tonic
Yeah,
in the glass, trying to go with the Florida trend.
yeah.
And I just started at Balchem, and I'm the technical services specialist. And I actually did my PhD at University of Illinois with Phil Cardoso. So that's kind of where my background in dairy cows stems from. But I'm originally from Florida, so
Oh, is that
happy to
right?
be
You're
back
home.
at University of Florida,
And what part of Florida did you grow up in?
Orlando.
Orlando.
Yep.
Okay, very well. And for this episode, our color analyst is going to be Dr. Corwin Nelson. He's from University of Florida. Corwin, just tell us a little bit about yourself and what's in your glass.
All right. So I'm an associate professor here at the University of Florida. Originally from Minnesota, so much colder area, but I've grown very accustomed to the Florida weather here now after
Yeah.
12 years here in Florida. So it'd be hard to go back to the colder weather up there. Um, and so I work on vitamin nutrition and physiology here at Florida, and yeah, happy to be a part of what we have here today. So what I'm drinking here basically looks like colored water, and
Yeah.
it about tastes the same too.
Is that
So
right? It's kind of light.
it's a very light beer.
Okay. All right. We could get another one if you'd like.
No,
Maybe just drink two and it'll.
I have ways to go yet tonight.
All
So
right, there you go. I get it. Um, our guest tonight is Dr. Lance Baumgard. Lance, you're no stranger to the pub. Been here a few times. Thanks for coming back. Lance is from Iowa State University. He gave a talk today at the Florida Ruminant Nutrition Symposium titled "The Importance of Gut Health to Drive Animal Performance and Health."
That's right.
What's in your glass, Lance?
Well, it's Angel's Envy. So my wife and I and some old college friends from Cornell went to Kentucky, Louisville in particular, late last summer, and took a tour of a variety of distilleries. And Angel's Envy was one of them, and I really like it.
Yeah, I want to go to that one. I have an envy myself. The difference between yours and mine is I don't have the fancy ice cube in there.
Yeah,
So
this is like a metal cube, so it doesn't get watered down, but it
yeah,
stays cool.
yeah, nice, nice. If you wouldn't mind, just kind of give us maybe an outline of the talk you gave and some of the key points to provide a basis of our discussion.
New research is changing everything we thought we knew about choline's impact on the cow and her calf, and top scientists have a lot to say about it. They are presenting new research that supports choline as a required nutrient to optimize milk production, choline as a required nutrient to support a healthy transition, choline as a required nutrient to improve calf health and growth, and choline as a required nutrient to increase colostrum quantity. This new research is solidifying choline's role as a required nutrient for essentially every cow, regardless of health status, milk production level, or body condition score. Learn more about the science that is changing the game and the choline source that is making it happen. Reassure precision-release choline from Balchem. Visit balchem.com/scientistsay to learn more.
Yeah, so the talk today, I went over different stressors, and seemingly they're very different. Heat, stress, transition period, off-feed events, etc. But the footprint and the metabolic and the inflammatory fingerprint of all those stressors is essentially the same. So when we think about why would that be, it's because essentially they all emanate from the gut. So stress in general negatively affects the gut. We're getting a better appreciation for that now in animal agriculture, but of course we've known about this for 150 years, right? Everyone, maybe not everyone, but many people know about how soldiers war fighters experience a lot of leaky gut problems, gut ulcer problems, and that was been documented in the American Civil War. So I think we're getting a better understanding of how stressors on farm, typical on stressors that probably every farm has, negatively influences the gut barrier function.
So, how does stress then impact the gut and cause leaky
Yeah,
gut?
yeah, well, that's a great question, and I'm sure there's some mechanisms that are still yet to be discovered. But the 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 one that I think is probably the most likely is an immune cell called a mast cell. And everyone who's listening to this podcast probably has some familiarity with a mast cell because when they reside in your skin epithelium and they degranulate, they cause a rash. And so if you have the red bumps, redness on your skin, to get rid of the rash, you take an antihistamine, which affects the mast cell. But most of the mast cells live inside of your intestine. And when you get stressed, the enteric nervous system releases corticotropin-releasing factor, which then binds to the mast cell. The mast cell degranulates, and there's a variety of things inside the mast cell, TNF-alpha, proteases, histamine, etc., which then causes the gut to become leaky. And the person who's experiencing the stress then recognizes the immune response to the invading or the infiltrating noxious antigens like LPS or lipopolysaccharide. And you can feel it, right? You'll hear kids say, "Well, I got butterflies in my tummy," or "I got knots in my tummy."
Yeah.
Some people get so stressed before big exams or during harvest or whatever that they vomit or they get diarrhea. So this is the really the connection between where your nervous system is communicating with your immune system, and the end result is GI tract pathology.
Okay. And so, how does that negatively impact the animal, the human?
Yeah, well, so once the GI tract barrier becomes compromised and leaky, well, then you end up getting infiltration of antigens like LPS, which then stimulates the immune system.
Yeah.
So essentially, you're getting immune activation stemming from your gut, right? And then, of course, immune activation causes you to go off feed or to lose your appetite. And so all the downstream cascades of this are similar to anyone else who gets, lung infection or a virus, a cold, any other type of infection that we all, familiar with, where you get tired, lethargic, lose your appetite, soreness of your muscles, etc. So the leaky gut, the footprint of that, it really isn't any different than any other infection.
Okay. And so, does this it'll heal up on itself if there's no longer stress?
Yeah, of course, chronic stress it has its negative implications
Yeah.
as well. But luckily for the gut, the gut does heal fairly quickly, right?
Yeah.
And so, like some of the data I've shown you today with how the gut becomes leaky in response to feed restriction, well, with time, that gets better, and that's part of the acclimation phase to a stress, which I think makes sense, right? Most stressors, like heat stress, for example, the early stages of a heat stress event is much more severe than a couple weeks later.
Yeah. And so, let me guess, the way to solve leaky gut is avoid stress.
Try to avoid stress, exactly.
Okay.
Yep.
And if we can't?
Well, yeah, if you can't, right? I don't know if we have great strategies on what to do. There are obviously different. Uh, so the stress causes the leaky gut. So of course we could try to target the gut permeability itself, and
Yeah.
there's a variety of dietary strategies to do that. The other one is how stress allows pathogens to adhere to and flourish at the apical membrane of the small intestine. So I think strategies to either bind pathogens or to curb their proliferation would be is a good strategy. And so there's a lot of strategies we can use. There's no silver bullet with regards to gut health. At least I've
Yeah.
not seen one.
Yeah. Yeah.
So, Lance, I have a question for you
Yeah,
in that regard. If it's mast cells potentially that's causing the leaky gut, why
yeah,
can't we just give dairy cows antihistamines? Give them some Claritin.
yeah. I've thought about that too. Um, yeah, I'm not sure if that's actually ever been tried. I haven't dug into that literature. You think I had, but I don't think it's been. So we've tried some mast cell stabilization experiments.
Okay.
Okay. Um, and we did it in pigs. And really, what we're doing is doing what Adam Moser at Michigan State is doing, and he's the leader in the animal agriculture world of this in this discipline or this area. And so we tried giving a mast cell stabilizer, or essentially something to prevent the mast cell degranulation during heat stress to
Mm-hmm.
pigs. And we didn't have great luck with that. That's not to say there's not still promising, you know, a promising area of exploration, but I think it's still pretty new,
Mm-hmm.
right? Our understanding of mast cells and their involvement in this is still fairly new. So I think you'll see a lot more investigations looking at different mitigation strategies soon.
Just to tie up into that question or that concept too, you always got to think about what are the consequences then of disrupting the normal process, right? There's
Yep.
a reason for those
Exactly.
mast cells to be there and to give that reaction. And just like you talked about in your talk, if you go and give a cow Banamine for consecutive days there on parturition or after parturition,
Yeah.
it has a negative
It,
consequence, right?
yeah.
There's a reason for
Yes.
that inflammatory process to be taking place. So, in the same place, at the same time, we got to always think about what every process that's taking place in the body, what is the role of that, and what happens if you were to actually stop that.
Well, and I do wonder just a little bit with that concept is that during transition, it makes sense because the cow's going to have to calve, and we haven't induced the cow into calving. That's a normal biological process. But some of these evolutionary fight or flight responses don't necessarily have to happen. The cow doesn't have to feel like she's running from a tiger if we have music on in the milking parlor, right? So if we, in those circumstances, if we can reduce the stress response, does the cow still turn out okay? Even if it,
Yeah. Yeah. A couple good points that you both brought up. I'll go back to you first, Corin. One, I think it's really important for scientists to think of biology within an evolutionary context. And I think oftentimes we don't, right? If biology is favoring this amongst different species, um, there's got to be a reason,
Mm-hmm.
right? And so we want to fix things, right? Scientists and veterinarians, that's what we want to do. We want to fix them, we want to intervene and fix things, and maybe that doesn't need to be fixed. Your question about or your comment about the parlor, I think is important too because the parlor is an area where I think an animal can get stressed. Right. I was talking to some former students, Megan Abate and Brady Gates, and they're talking about some of these parlors are dark. The cows can't see where they're walking. I've seen videos of clean alleyways and there might be one area where the concrete is grooved and you'll see them walking on that. So I don't know. I think there's a lot of places walking from the pen to the parlor, and of course the crowd gate.
mm-hmm.
Right? It's loud. The parlor's loud. Can be dark. They can't see where they're walking. These are all small stressors, but death by a thousand cuts.
Yeah.
You think of that, first calf heifer in particular going into the parlor for the first time. So there, she just had a calf for the first time.
Yeah,
She just more than likely got moved to a new
of
pen,
course.
and then she's going through that parlor and wondering what's going on to me here.
Yep.
Yeah, that's a lot going on for that heifer, and unfortunately, and we really try to make sure we coach everybody on just calm managing those animals. Well, that heifer isn't going in, and things start to get more chaotic very quickly, right? So we really coach against those things, but the reality is all of a sudden you see chaos start to take
Yeah.
place, and that really puts that heifer, and you can see the effects on that animal when that's taking place, how it really slows them down, just being comfortable going into that parlor.
Yeah. Yeah. I think there's just a lot of opportunities, especially in very early lactation. Right. Think about she's got new pen, new diet. We just took her calf. She's learning a new routine of getting milked. Right? And if she's getting thrown into a fresh pen with a bunch of older cows, there's just and if it's overcrowded, there's a lot of stressors that get stacked on top of each other. And in the field of stress physiology, there's a term called stack stressors, where an animal will typically be able to tolerate one stressor, but if you throw another one on top of her, and if that other one was isolated, no problem. But when they start stacking on top of each other, then their ability to tolerate a stress or survive that stress is compromised.
So we see heifers, I feel like a lot of times maybe don't have as difficult of a transition as multiparous cows. But kind of what we're discussing now, it seems like maybe they're more stressed just because it's all brand new. So is it just that they can take those insults a little bit better because this is the first time
Hmm.
through, or kind of what do you think about
Well, I
that?
guess it may depend on how are we judging whether or not they transition better.
Mm-hmm.
What criteria are we using? Um, their
I,
incidence of milk fever is less, of course, but
yeah, I think, well, there's maybe a couple things there. Metabolically, they're perhaps not as challenged much
Mm-hmm.
because they're not milking
As
as
much.
much. There's not as much of a metabolic challenge. But on the flip side, you look at incidence of metritis. Yeah, that's generally going to be greater in heifers than what you'd find in your multiparous cows.
hmm
So it, there's differences there, but yeah, how do you? It's difficult to compare how do they transition of a primiparous cow versus a
yep,
multiparous cow.
yep, yep, exactly.
So you might find this surprising, but I listen to Joe Rogan a lot, and he, he purposely does cold plunges, and he goes in saunas, and it does it regularly, and that's done for health effects. And so, how does that jive with what we're
Yeah,
talking about with stress causing leaky gut?
yeah. I think this fits in kind of with Jose Santos's question this morning, and he said, well, humans do intermittent fasting all the time,
Yeah,
and obviously without negative consequences, and arguably with benefits.
yeah,
And there, I think the difference is when a farm animal goes without feed for a few hours, they don't know they're going to be fed again, right? So now we have a psychological stressor involved here, where when you and I jump into a cold bathtub
yeah.
or choose not to eat for a day, we know that we can always go to the refrigerator and
Yeah,
right and eat again.
I usually
So
do.
yeah, exactly. So I think there's comparing how Americans, how humans respond to voluntary stressors,
Yeah.
right, is different than what a farm animal
Mm.
does.
Is there a psychological aspect to it?
100%.
Yeah,
Yeah, I think so. I really do.
interesting.
Oh,
Hmm. What if there's anything we can learn there to help animals adapt? I don't know.
yeah.
But as you bring that up, just that thought came to mind, and just how a conditioning animal, and we talk a lot about early life events and how that has long-term impacts, and um, that's becoming a very common practice for calves to be raised elsewhere, right? So it's again that stressor incurs early in life. So in that first week of age, they may be shipped off to a calf ranch, raised there. They're going to be maintained within that system there, so minimizing stressors. But eventually, those animals got to come back to their home place,
Yeah.
and so they're being conditioned. So it'd be interesting to see as we collect more data on this process, and some people are working on that, but collect more data on just that type of management, how that has an impact on the future performance of those animals.
Yep. That would be very interesting. We know that young calves that have some type of immune activating event, whether it be scours or especially pneumonia, right? Their future productivity is compromised. Um,
Hmm.
so if you can translate an infection like those two are to rough handling or just normal psychological stress, that would be very interesting.
Not that we're advocating rough handling
Of
or
course, no,
psychological stress
no,
for an animal by
right,
any
right,
means, but
no, no,
So, Lance, in your talk, you talked about people in army and soldiers and
yeah,
how they get ulcers and that sort of thing.
yeah.
And I have an equine background, so very well versed in ulcers that happen in horses. But do we see the same thing happen in ruminants or cows in stomach or small intestine or hindgut?
So that's a great question, Laura, and I don't know if we do, but I don't know if we're not. I don't know if we're looking.
Mm-hmm.
What percentage of animals that die on farm actually get a thorough posting? It's probably pretty few. Um, but do you remember the picture I showed today of the bloody stomach
Mm-hmm.
after immune activation? I've ran into vets who've talked about bloody abomasums before,
Okay.
and so I think it happens.
Yeah.
Um, an ulcer where you can visibly see with the eye. We oftentimes affiliate that with the rumen
Hmm.
and rumen acidosis or chronic rumen acidosis, but many of these small um, hyperpermeable regions probably aren't visible with the naked eye that would see the typical posting.
Yeah. And you mentioned again when you showed those pictures of, and maybe this was a different picture, but with the villi,
Yeah.
of the villi that was healthy and then
Hmm.
heat stress and then pear fred. And the heat stress one was just markedly
Yeah.
worse. And so were you then attributing that a little bit to that histamine response? Is that why the villi is that worse or?
So we almost got to go back to like 2009 or 10 when Rob Rhodes and I were collaborating on all this stuff. Most of what we chase in animal agriculture, specifically this area of stress physiology, comes from human, physiology. And of course, the U.S. military is very interested in heat stress because oftentimes our soldiers are in hot environments, and they're wearing these huge, 50, 75-pound packs, and so there was a guy from the University of Iowa. Shoot, I'm forgetting his name right now, but he was the one who first started to characterize this leaky gut in rodent models, and then the Department of Defense described it really nicely in American soldiers. Um, so that's why we started chasing it. Now the morphological changes that I showed you today, I mean, I don't know if that could all be, you know, mast cell mediated. Like I said, there is definitely a reduction of blood flow to the GI tract during heat stress, and that we used to think that was the whole reason why animals get leaky gut was there was a reduced perfusion of the sphinctic bed, but um, cold stress also causes leaky gut, and of course now we have an increase in blood flow to the core. So, how much does blood flow contribute to this leaky gut pathology? I don't know, but probably some percentage, yeah.
Okay. Does cold stress have that? And we haven't really studied cold
No,
stress all that much, so you probably don't have the answer. If it does have that same negative effect on the villi as.
that is much less studied, cold stress, and that's for sure certain in animal agriculture.
Hmm.
So the cold stress literature is almost pretty much all rodents.
Hmm.
The biology of cold stress is pretty much all small lab animal models, but it's hard to study, right? A lot of that is simply just logistics and infrastructure. We can build little chambers to get animals super hot. It's difficult to get them really cold,
Hmm.
especially an adult dairy cow, right?
Yeah,
You got to get really cold for a cow to get stressed.
good point.
Hmm.
So just thinking about the going back to the transition dairy cow and this phenomenon of how you see that you'll see that or going back to gut permeability
Yeah.
with that and maintaining feed intake. So what fascinates me all the time is you see these cows, despite all these challenges, just rocket
Yeah.
through there, and they'll be up and milking 150
Yeah.
pounds a day in no time at all. And those cows fascinate me. What is it about those cows that makes them get through that, right? They've experienced all, you got them on the same diet,
Uh-huh.
you got them in the same environment, and what is it about those cows so it's a question that fascinates me. What makes them unique?
Yeah. So my knee jerk reaction or my knee jerk answer as well. Those are the ones that just simply haven't had as much pathogenic inflammation as the cows that are crashing and burning. Um, but then the question is, well, why would that be? Like you mentioned, they're all fed the same diet, right? Maybe it's more tissue trauma, damage to the uterus during calving. Um, Maybe they're just super sensitive to immune activation. And maybe there's some genetics to that,
Mm-hmm.
and I'm sure there probably is. Um, yeah, when you were describing that, it made me think of pigs. The fact that pigs can get to 300 pounds within 6 months of age is just shocking to me. When you think about how many immune challenges that they go through, right? They live in pretty small pens, right? And yeah, It's actually, when you think about all the stressors that farm animals have, the fact that they can be so productive is quite amazing.
Mm-hmm.
Cor-
Yeah, it truly is. And then you got a cow that, and I know you've said this before in some of the talks you give, like to say that we often talk about the cows in a stressful environment. Sometimes you say, well, are they really if they're
Right.
milking 150
Yeah.
pounds a day? Yeah, how stressful is that? Like
I
it's
would say she's
it,
the least stressed animal,
yeah,
right? The highest
yep,
producing animal in the farm is the least stressed animal in the farm.
mm-hmm,
And of course, that's kind of counters what we oftentimes hear. I hope that it's an antiquated viewpoint, but that high production is stressful. And I just don't think that can
yeah,
be, right?
right,
Because universally, if you ask scientists, hey, does stress reduce an animal's productivity? Of course, the answer is always yes. Well, if stress reduces farm animal productivity, well, then how can high production be stressful? The two just don't dovetail together,
mm-hmm,
right? But that's still a very common held
right,
dogma among scientists and some scientists, some veterinarians, some farmers. I've
mm-hmm,
heard farmers say this, man, my cows are milking too much. I'm making too much money.
Yeah.
Corin, going back to what you had said about that there are some cows that just really take off, and I've had that thought about a lot, mostly on the efficiency side of things. That you can look at two cows side by side, raise exactly the same, and one can be substantially more efficient than the other, and just trying to kind of figure out why. And I do wonder if it has, of course, feed efficiency is going to be genetic to some extent, but when you get in a herd of cows, there can be one or two that are a lot more likely to walk up to you and some that are more skittish. So I do wonder if it has a quote unquote personality
Yep.
differences to
Good
some
point.
that are more
Yep.
attuned to be stressed from a small change, whereas others that are more resilient to
Right.
that change, and whether we've accidentally picked for one or the other in some
Yeah.
herds.
I think the beef industry's done a really good job of trying to quantify that. Don't they calculate the speed at which an animal leaves the chute?
mm-hmm,
That's really quite creative.
Mm-hmm.
And then if I remember right, the animals that leave the chute the fastest are the least efficient. Is that
I would say
is that how
yeah,
those
it
ones
goes?
are
yeah, they are,
probably
yeah,
scared.
Yeah,
So they're
they're freaked out.
bolting out there.
yeah,
Yeah.
yep.
Yep, exactly.
Well, yeah, and to that point, you think of just the variation in the cow's temperament that you see out there, and how they're going to deal with new situations, and those that are going to just kind of be that calm cow that go through anything, they're more than likely not going to be disrupted by pen movements, anything like that. So,
Yeah, exactly.
It makes a lot of sense. Are the genetic companies, can they identify that in the genome and maybe they ought to start selecting for that?
Brave
Yeah,
cows.
could be.
Brave cows? Yeah.
yeah, we obviously we've selected for temperament over the years, and done that. There's still the variation within that too. That how much can you select for, continue to select for, to identify those cows. So we obviously have done that over the years to
Yeah.
get these very docile Holstein cows, and then of course that people come to the university farm. We handle cows so many times, and then you walk out into a pen and any one of them, you just walk right up to them because they've been handled so many times. So
Yeah.
Hmm.
Yep. I was in Israel not long ago, and a bunch of veterinarians who've become good friends of mine. They put up big signs on their clients' farms saying, minimize cow touches. And I can't wasn't able to read the writing, but it's something like, they're not pets.
Hmm.
Right, leave them alone. Let them be cows. And I think that's I was very impressed with that.
Hmm.
One thing that was interesting, if we're getting into the storytelling portion of this podcast, is that
We're always in the storytelling portion.
during my PhD, I did transition cow trial in University of Illinois. We do really good research, but the dairy isn't fantastic, so it's a little small. So we had to buy some cows. So we bought 20 cows when they were, I don't know, negative 50 days before calving, and we did quite a bit of immune response and that sort of thing that we were measuring. And those 20 cows, thank goodness we had them in their own blocks so that they were kind of compared to each other. Their immune activation was through the roof compared to the cows that we had on the dairy.
Mhm.
And it was, I mean, you could spot it easily that those cows were ones that we bought. And they, honestly, performance wise, milk yield wasn't a huge difference. But when we were looking at, say, haptoglobin, their haptoglobin was through the roof compared to the cows that were on the dairy still. And so it
Mhm.
almost seems like those cows were obviously still performing when they at least came in stressed. They started stressed, but then they were, and whether they were just higher maybe
Mhm.
yield to begin with.
Yeah.
But yeah, their immune response was quite elevated compared to
Yeah.
the other cows.
It's interesting you said that because we have a paper that's in press, so you could find it in GDS. Sonia Rodriguez Jimenez is the first author, and where we created a chronic uh, inflammatory model, 7 days. And so we were successful finally after trying 3 or 4 times, but we finally were able to get animals to be inflamed for the whole 7 days, chronically inflamed, right? And of those 7 days, though, the negative effects on production was only in the first couple of days. So productivity and feed intake acclimated to the chronic immune activation,
Ah.
but they remained inflamed the entire 7 days. So then now, and that makes me worried a little bit about our understanding, or at
Mm-hmm.
least causes me to question our understanding of transition cow inflammation. How causal is it to poor productivity? Because here we just got a model where by the seventh day they're super inflamed. If you take a blood sample, you'd say this cow looks horrible, but it's milking and eating like a champion. So there's obviously a disconnect in these chronic models of inflammation and productivity. And so, like in a transition period where they might be inflamed for 10, 14, 20 days,
Mm-hmm.
what does that what does that mean? What are the implications to our understanding of how inflammation affects transition period
Yeah.
productivity? I don't know the answer to it.
Yeah, it's a difficult concept, especially because those cows were moved a little ways after dry off, so they kind of had that insole to dry off. Were able to maybe recover from that, and then they were brought to a new farm and then incorporated into a whole new herd and that sort of thing. So then they had that inflammation saying starting at 40 days before calving.
Yeah,
So they kind of had that build up already, but didn't seem to hurt them on the back end of calving at all.
yeah, yeah.
To your point there, Wes,
Lance,
Lance. I don't know why Wes just popped into my mind
I have an uncle named Wes.
Okay. um, the immune system, like the endocrine system, is full of checks and balances, right? So you can have some activating factor elevated, but is there another response to that that helps maintain a balance there? And so the immune system is full of those checks and balances. We know that in T cells, for example, you got your activating T cells, but then there's your regulatory T cells that go along with it to maintain a balance there. And we know from diseases like autoimmune diseases in people, for example, a lot of the manifestation of disease really comes from not so much always the activation part, but a dysfunction on that regulatory
Yep.
aspect there. And we really don't have a handle that in cattle in terms of that inflammatory response and how they then balance out the resolution of that inflammation. We've talked about it a lot, but we really don't know much about resolution of inflammation.
100%. And what you were just got done describing reminds me of something what Dale Bauman always used to say, that in biology there's redundancies built in, and the more important the system, the more redundancies there will be. And probably speaking with regards to, if you had to prioritize, which systems are most important, arguably the immune system is probably right up there with the central nervous system, right? So, to his point, and to your point, maybe this the immune system there's all these checks and balances and redundancies built in to make sure, hey, I need to survive this insult, right? And yeah, those are things we need to
Yeah.
figure out.
So sometimes we look at markers, say like haptoglobin, TNF-alpha, IL-6, and those will be elevated, and they generally are very good indicators of that animal's inflammatory status. But then how are they still function in response to that? And I mean, we it goes back to this. We know very well that a very good indicator of animal health is animal performance,
Exactly.
right? If they're performing well, it's a good indicator that they're a healthy animal.
Yeah, I'm unaware of any illness where, or I'm unaware of any situation where the animal's productivity is not reflective of its overall health status. When and maybe I'm just not thinking of something. Maybe you guys can think of something, right? When would an animal have some type of disorder, health problem, immune activation event where productivity wasn't affected? I can't think of any.
No, I
It
mean,
it may be hidden to the point that it's not necessarily noticeable to us, but it is. Like we know that from subclinical mastitis. We don't see the clinical manifestation, but we also know from collection of a lot of records of animals, elevation of that somatic cell count, even if it's subclinical, you still have a decrease
Cost
in
you
milk
milk.
production. Yeah.
Exactly. No, 100%. That's why I'm totally agreeing with you that our best marker of productivity, of immune health status
Mm-hmm.
is
Productivity.
productivity.
Yeah.
so is there any chance that stress and immune response during transition starts to get into that chronic state that the cows are acclimating to that stress? Say if it starts prior to calving, they start to acclimate to it already, and that plays a part into how they're able to be high producing by day 7, say.
Mm.
Do you think that chronic stress has any play in there, or that it doesn't because we have these an insult and then another insult and it kind of starts that timeline over?
My guess is that they can acclimate to a stressor like overcrowding, you know,
Noise.
noise, those type of things
Yeah.
they can acclimate to. But if it's an infectious stressor like mastitis or metritis or leaky gut or pneumonia, that's hard to acclimate to, right? You just
Yeah.
got to let the immune system run its course then. So I think the two are a little bit separated, although emotional stress causes immune activation, via the gut. But mastitis, metritis, and pneumonia and gut inflammation, I think, are a little bit different than the psychological stressors that we've been talking about today.
So during transition, it could just be a combo of both.
Yeah,
So they have
100%.
both of those going on.
Yeah, well, I think the Florida group has done such a nice job of describing what percentage, Corwin, of cows calving have some type of subclinical endometritis. It's like over 50%, or I can't remember what John.
Yes, if you go to, and there's been different rates, but yeah, I've seen 40 to
Yeah.
50%, depending on the population that you're studying. But yeah, and I think truly our rates of metritis are actually much more than what farms will typically report. A lot of farms say, "Oh yeah, we don't have any metritis." Well, that's because you don't measure it.
Yeah.
Like they have it. Like and it's I think even well managed herds, it's still probably running anywhere from 10 to 15%.
Yeah.
And then that's
That's clinical.
metritis. Yeah, clinical metritis. That's not talking about subclinical endometritis, which would be much higher.
Yeah. Yeah.
So that brings up a interesting point I've seen in this in a couple different data sets, and there's some data that's been published too that suggests the same thing. So we've seen cows that have metritis. You already see a decrease in feed intake
Before calving.
even before
Yeah.
calving. Right, and we've seen this at one is at feed intake. Have another large data set from a commercial herd, a couple thousand animals, and we looked at body condition score, and there we even see body condition score has declined before calving in these cows that develop metritis. So it goes back to what's going on there in that prepartum period. That would is it
Yeah.
what would be causing them to decrease their feed intake?
Mm-hmm.
And we've corrected for factors like lameness and that, so it's taking that out of it. So what other factors could it be? Is it, they're not overcrowded, so it's not necessarily competition for bunk space
Mm-hmm.
that you have there. So what is it that's taking place and causing that decrease before calving?
Well, I don't know the answer, but a couple things I want to comment on your is that so traditionally then the reduced feed intake before calving has been blamed for the post-calving pathology, in this case metritis, right? And I think that had been an incorrect assumption.
Mm-hmm.
So I remember talking to Pete Hansen about this exact biological phenomenon. Like, hey, can the uterus get leaky before they calve? And he's, nah, probably not, right? But he did talk about vaginitis before, possibility before calving. And I think I'd also don't think it's a coincidence when you take a look at animals going off feed before calving. Not first of all, not all animals go down and have a reduction in
Hmm.
feed intake before calving,
Right.
but the ones that do, typically starts about 14 days prior to calving. And I don't think it's a coincidence that the mammary gland is also initiating lactogenesis at about that time. So my assumption, my guess would be, total hypothesis, that the immune activation is stemming from the mammary gland on those cows before calving, which is reducing feed intake. And now we have a cow that's in the midst of a mild immune activation prior to her even calving. And now you have a dilemma of the immune system post calving, where you have to um, take care of both a mammary and a potential uterine infection. I'm just totally speculating here.
No, I get the wheels turning
Yeah,
here, thinking, well, we measure, we can measure somatic cell score of colostrum,
yeah,
find out how much indication of inflammation you have in the udder there
yeah.
at the time of calving. That would have been occurring during that period of mammary development.
It's
I
been a,
got I got one more thing to go work on now.
Yeah,
So
there you go. Job security, Corwin.
yeah.
this has been a great discussion, and I hate to shut it down, but Lance, you have a
Got a
plane to
flight to
catch.
catch. Yeah.
So,
All right.
yeah, no, and I think we're doing fine. But as we wrap it up, I'd like to kind of get you guys' input in terms of what are some key takeaways from this discussion today. It's been great. Laura, if you wouldn't mind, what's some of the key takeaways for you today? I'm gonna start with you.
Tonight's last call question is brought to you by Niehues Precision Release Niacin. Niacin is a proven vasodilator for heat stress reduction and a powerful antilipolytic agent for lowering high blood Niehues in transition cows. Protected with Balchem's proprietary encapsulation technology, you can be sure it is being delivered where and when your cows need it. Learn more at balchem.com/Niehues.
I think for me, a key takeaway, and this is when I'm thinking about inflammation and gut health and that sort of thing, is that there can be a variety of stressors that are causing that. It may not just be one thing, and how we go about treating it, we want to be careful on how we go about treating it to make sure that we're not blocking a response that needs to happen. And I think that's the biggest thing, that when we go back to think about research and that sort of thing, is that we want to make sure that we aren't blocking something that has to happen in order to try and make the cows produce more milk. Likely that they won't produce more milk at
Yeah.
that point.
Mm.
Yeah.
Corwin?
Yeah, just thinking about that of and going back to my experience in the last year of helping manage our university dairy, and go in a situation like that. One, I realize every dairy farmer out there how they're going to get an ulcer from the stress that they deal with, and, opportunities or stress that they deal with. But the you can look at your situation and see, man, there's so many things I need to go and solve. Yeah, there's a problem here, problem here, problem here, that it just can be overwhelming to solve all those things. And we know how to manage cows very well, right? We see it. We have very good examples. Here's what we need to do for this transition cow to do it right. And we can go around the world and find the great examples of these cows and herds that are just doing amazing. But then you're also faced with, man, I can't get it all done at once. But identify that low-hanging fruit of, well, here's a simple solution that I can fix right now. Solve that one now. Then go to, okay, what's the next one that I can solve that one, and start, identifying that low-hanging fruit to work on implementing some of these easy changes to help these cows through this period.
Yeah,
Yeah.
excellent points. Yeah. Lance?
Well, I'm biased working in the area, but I think the industry is becoming increasingly aware of how the gut health, gut barrier health dictates overall animal health.
You've been a big part of that.
Well, I'd like to think so. Thank you for saying that. So, uh, I think we need to educate nutritionists, veterinarians, and farmers about how, hey, we want to minimize environmental pathogen load.
Hmm.
I think that is just huge.
Hmm.
After living in Arizona for 10 years, having visited Saudi Arabia and Israel, these cows that are in super stressful environments, but they're rock stars, I think that occurs because the environmental pathogen load is so low. Dry, dry, dry.
Hmm.
Anyway, educate on the importance of environmental pathogen load and educate on um, gut health, and then I think there's a huge opportunity then for the feed industry, right, to come up with strategies to um, help carry dairy cows get through this stressful period.
Yeah. Well, thank you guys. I was reflecting during the podcast recording here. You know, my favorite part of my job is that I get to spend time with some very smart people and sit around and talk and with them and have some beverages and so I'm truly blessed, and so I want to thank you guys for joining us here.
Thanks for
This
having us, Scott.
yeah,
Thanks for
this has
having
been
us, Scott.
awesome. Yeah, it's been great. So just want to thank you guys.
Thank you.
Uh,
Thank you.
yeah, to our loyal listeners out there in cyberspace, thank you for joining us once again. Hope you learned something. Hope you had some fun, and I hope to see you next time here at Real Science Exchange, where it's always happy hour and you're always among friends. Cheers.
We'd love to hear your comments or ideas for topics and guests, so please reach out via email at anh.marketing@balchem.com with any suggestions, and we'll work hard to add them to the schedule. Don't forget to leave a 5-star rating on your way out. You can request your Real Science Exchange t-shirt in just a few easy steps. Just like or subscribe to the Real Science Exchange and send us a screenshot along with your address and t-shirt size to anh.marketing@balchem.com. Balchem's Real Science Lecture Series of webinars takes place on the first Tuesday of every month, with the top research and nutrition topics that will impact your business. We also include small ruminant, monogastric, and companion animal-focused topics throughout the year. Visit balchem.com/realscience to see the upcoming topics and to register for future webinars. You can also access past webinars and search for the topics most important to you.